You have a website, a list of images to display, and a little CSS knowledge. And this is the result you get in this video. Inspired by astronauts far from home, bringing nostalgia to the images. In this project, I've prepared the background image and the astronaut image beforehand according to the theme. The first step is to embed the CSS file into the HTML. On the right, we currently have an empty web page. I'll create a scene class. This will be where we create the slider image. Inside, it will first contain the model image. To distinguish it from the slider images, I'll name it Herman. In the body, I'll first remove the default margin. Paste in the background image that we prepared beforehand. With the center and bottom positions, it won't repeat, because its size will be covered to fit the current screen. In the scene, I'll set the height to the current screen height and add a position relative, the main purpose being to allow child elements to move freely according to the scene's coordinates. Finally, let's move on to the human model. Use position absolute to allow it to move freely. I want it 10% from the top, along with the combination left 50% and translate X minus 50% to center the model along the X-axis. Finally, it will have a width of 70% of the current screen width, but must not exceed 520 pixels. Now I'm creating another image representing the rotating images in the slider with the class name AlfOrbit. The images in the slider are very special images whose dimensions we can't be sure of, so we need to make them all the same size. Don't forget to add object fit cover so the images aren't distorted. Add border radius to bend the four corners. To change its position, we'll continue using position absolute with the left 50% method. I use margin left with a value equal to half the width to bring it to the center. I don't use transform here because we need transform for the more important animation task. Finally, the top 30% method. If we want this image to move freely in 3D motion, first we need to convert the 2D space containing the images into a 3D space, right? The space containing the images is the scene class. We use the transform style property preserve 3D to create a 3D environment. This space will have a depth of 1000 pixels. I'll temporarily blur out the human image so we can clearly see the orbital motion effect. Imagine, in spatial geometry, there are always two axes, X and Y. And by default, every image is centered on one of these axes. So if I wanted to rotate along the Y-axis, I just use rotateY. From 0 degrees to 360 degrees is one rotation. Now, based on this idea, I created an animation with the same name. It will run for 2 seconds, and the number of rotations is infinite. The task of this animation is to make the image continuously rotate from 0 degrees to 360 degrees, and this is the result we get. In 3D space, an additional axis is added, the Z-axis. This Z-axis is the line from our eyes to the center of the axis. So if we want the image to move away from the center axis, we just need to declare translateZ, with the value being the distance from the image to the center axis. And that's how we get an interesting animation effect. Now I'll show the Herman clearly again and give you a surprise. When the image is close to the screen, it will be in front of the Herman, but when it moves away, it will automatically disappear because it's behind the Herman, because the Herman is also in 3D space. And by default, the Herman is right in the center of the coordinate axis. So from the user's perspective, the Herman is obscuring the objects behind it. First, I'll slow down the animation to make it easier to see. Once one image is running, I'll add 4 more images, all with the class orbit. If you only see one image on the screen, that's perfectly normal because all 4 images are running the same animation, overlapping each other. To see the other images, we just need to add an animation delay so that the subsequent images start moving later than the previous ones, following each other in sequence. And now it's there. However, writing CSS properties directly here isn't a good idea, so I'll replace it with a variable declaration, whose value is the delay time, following the rule that each subsequent image will run 1 second slower than the previous one. In CSS, I just declare the delay time using the value of the delay variable. But we'll see an error here, that is, when the user first accesses the page. The images that haven't reached their running time yet will be displayed right here. To solve this problem, I multiplied the delay time by -1. And all the issues were resolved. Simply put, if the time delay is 3 seconds, it means the element is in the queue for 3 seconds. But if the delay is -3 seconds, then when the page starts, the element has already been running for 3 seconds. And therefore, when the page starts, all the images have already started running. Now let's move on to the second issue. Even though the animations aren't overlapping, the time isn't evenly distributed, leaving a lot of empty space on the slider. Imagine this. If we have a list of objects moving in a circle, each circle has a 1-second delay. According to this formula, even the first item should be 1 second behind the last item. So by replacing the value with -- delay, we have the last element starting to move after 3 seconds. Therefore, the first item at this point will have a time of 4 seconds because it's 1 second behind the last item, and that's also the time it takes for the animation to complete one circle. Of course, we can't directly write the animation time in CSS. Instead, I'll create a variable named time, just like we created the delay variable earlier. But since the animation duration is fixed, I just declare it in the parent class scene, instead of writing it multiple times for each image. Then I just replace that variable here, and that's it. Now I'll create more images to check if any errors occur. I'll create about 10 images. Each subsequent image will have a delay 1 second longer than the previous one. And the total animation time will be equal to the delay of the last image plus 1 second, which is 10 seconds. It still works very smoothly, right?
Let's go back to the coordinate axis issue. With two coordinate axes, x and y, our eyes are currently positioned at the x0 axis, and the images are also located on the x-axis. So if I want to change my viewing angle, I simply rotate the x-axis of the entire 3D space to a different value, and then I will have a more aesthetically pleasing perspective. Feel free to experiment with different values to find a position that suits your own aesthetic preferences.
-15 degrees is the viewing angle I wanted. With a little more time, I think I can create a separate animation to change the viewing angle of this scene. I will create an animation for it, each loop lasting 5 seconds, and it will run countless times. In this animation, I simply change the rotateX viewing angle from -15 degrees to 15 degrees, a small difference to create a small but subtle movement. Now let's look at our result. Thanks to the changed viewing angle, the image in the slider also has an up and down undulating effect. Pay close attention to the model, Herman. It feels like he's actually moving. And that's all for today's video. Since it's a new channel, the audience is still small. I hope to receive your support through likes, channel subscriptions, and comments so I have more motivation to make more videos to share. Thank you very much, and I look forward to seeing you at this time every week.